Hello students, happy morning. In today's class, we are going to start the next new chapter, Introduction to Trigonometry. Trigonometry is a very easy and interesting chapter. What is meant by trigonometry? It is the study of relationships between the sides and the angles of a triangle. Trigonometry means the study of relationship between the sides and the angles of a triangle. So trigonometry has been introduced only in class 10. It's a new concept, but it's going to be really interesting. So we are going to restrict the study of trigonometry. Trigonometry means relationship between the sides and the angles, but in your class we are going to restrict the angles as only acute angles. We are not going to deal with any of the obtuse angle as far as your class is concerned, and we are going to deal with a right triangle as well, right? So basing on these, we are going to define the various trigonometric ratios and then trigonometric ratios of some specific angles, and then we are going to derive few identities also, and we are going to solve problems based on all these three, right? Now let us learn what is meant by trigonometric ratios and what are trigonometric ratios. So consider this is a right triangle, right angled at B, and we are going to define the trigonometric ratios for this angle A. Angle A, I have named it as theta. It is just the denotion, right? Then what is this side? This side is opposite to the angle. Opposite to angle A, opposite side to angle A. What is this side? This side is adjacent to angle A, adjacent to angle A, and this is our hypotenuse. This we know very well. The side opposite to right angle is our hypotenuse, right? And we are going to define the basic three trigonometric ratios. One is sine theta, cos theta, and is tan theta. And this is sine function, cosine function, and this is tangent function. In short form, we will call it as sine, cos, and tan, right? The sine, cos, and tan cannot work out without the accompanying of the angle. So without angle, if you write sine equal to, cos equal to, tan equal to, it doesn't have any value. The trigonometric ratios have value only when it is being applied on any angle of a triangle, right? So you should write sine A equal to, cos A equal to, tan A equal to, or theta, or the measure of the angle. If the angle is not there, it doesn't have any value, remember. So in hurry, in your paper, exam paper, or in your notebook, you should not write simply sine, cos, and tan without the angle. Now let us see what is sine theta. The definition of sine theta is opposite side divided by hypotenuse. Opposite to which side? Opposite to which angle? Opposite to the angle. The side opposite to this angle divided by hypotenuse. If I am going to talk about this A, then the side opposite to angle A divided by hypotenuse. So it is going to be BC divided by AC, right? And what is cos theta? The side adjacent to angle theta divided by hypotenuse. Since we are talking about angle A, cos theta is going to be adjacent side divided by hypotenuse. This is your adjacent side, right? So this is AB divided by BC. I'm sorry, AC, right? AB divided by AC. Then what is your tan theta? Tan theta is opposite side divided by adjacent side. Opposite side divided by adjacent side. Or else in terms of sine and cos, we can write it as sine theta divided by cos theta, because hypotenuse will get cancelled. So you will get opposite divided by adjacent, right? Which is opposite side BC, adjacent side is AB. So tan theta is BC divided by AB. I repeat, sine theta is opposite side divided by hypotenuse, cos theta is adjacent divided by hypotenuse, tan theta is opposite divided by adjacent. So if you know these three basic trigonometric ratios, you can win the trigonometry. Yes, if you remember these three, then you can do wonders in the chapter. You should not forget, alright? Then based on these three, we are going to define the next three trigonometric ratios. What is it? cosecant theta, secant theta and cot theta. What is cosecant theta? Cosecant theta is the reciprocal of sin theta. Cosecant theta is the reciprocal of sin theta. So C and S, remember, C does not go for C. It's reciprocal. So C will go for sin. Cosecant theta is the reciprocal of sin theta. Sin theta is opposite by hypotenuse. So cosecant theta will become hypotenuse divided by opposite. Yes. Similarly, secant theta is going to be reciprocal of cos theta. So it will be hypotenuse divided by adjacent. And what is cot theta? Cot theta is the reciprocal of tan theta, which is equals to adjacent side divided by opposite side. Yes, you have to remember these things. If you remember these three trigonometric ratios, these three automatically follows. This is sin, cos, tan, and this is cosec, secant and cot. Yes. And one more thing here is, if you know any one of the trigonometric ratios, any one among these 6 trigonometric ratios, we can very well find the remaining 5 trigonometric ratios. How it's possible? Because suppose if you know the sin theta value of a triangle, then you can find the remaining. How? The sin theta is going to tell which angle are we talking about, and the opposite side measurement of that angle and the hypotenuse measure of that angle, right? And since we are dealing with a right angled triangle, if you know 2 sides, we can very well find the third side by using Pythagoras theorem. And once we know all the 3 sides, we can find the remaining trigonometric ratios, because all the trigonometric ratios being defined based on the 3 sides of a right triangle. Right? And if we know the value of BC by AC, what does it mean? The ratio between the side BC and AC is that much. It is not the exact value. It gives you the ratio between BC and AC is that much. Right? And one more thing is, like the trigonometric ratios can be defined only for this angle? No. You can define trigonometric ratios for this angle as well. If you are going to define trigonometric ratios for angle C, then accordingly it will change. Which will change? The values will change, but the definition will not change. Sin C is going to be opposite side divided by hypotenuse. But when you talk about angle C, which will act as an opposite side? The side opposite to angle C is going to be AB. So sin C is going to be AB divided by AC. Right? And what is cos C? Cos C is going to be adjacent side divided by hypotenuse. So it will become BC divided by AC. So likewise, you can define the trigonometric ratios for any angle of a triangle. Right? So based on this idea, let us solve exercise 8.1. Now let us solve the first question. ABC is a right triangle at B is given in the question, and they have given directly the measurements of the sides. They didn't give you trigonometric ratio, they have given you directly the measurement of the sides. AB is 24, BC is 7. They asked you to find sin A cos A, sin C cos C. Right? So before we find the trigonometric ratios, we need to know the measurement of this hypotenuse. So let us apply Pythagoras theorem and then find what is your hypotenuse. Now see, we found what is the measurement of AC by using Pythagoras theorem. AC square equals to AB square plus BC square. So 24 square plus 7 square, which is 625. So square root of 625 is going to be 25. So the side AC is 25 centimeter. Now we need to find what is our sin A. What is the definition of sin ratio? Opposite divided by hypotenuse. So which is the side opposite to angle A? Which is the side opposite to angle A? BC. BC is going to be 7 centimeter divided by hypotenuse is 25. So sin A is 7 by 25. What is cos A? Cos A is adjacent divided by hypotenuse. Which is the side adjacent to A? The side adjacent to A is 24. So it is going to be 24 divided by 25. Right? Similarly, you can find what is sin C and cos C. What is sin C? Sin C is opposite to angle C. Opposite to angle C is 24, right? So 24 divided by hypotenuse is 25. And what is cos C? Cos C is going to be adjacent divided by hypotenuse. So it is 7 by 25. So which angle are you talking about is very, very important. So based on the angle only the ratios is being defined. Because trigonometry is nothing but the study of relationship between the angle and the sides. Okay. So analyze which angle are you talking about and then give your trigonometric ratios. Yes. Hope you understood. Let us move on to our next question. Now let us see how can we solve our second question. They have given you a right triangle in which PQ and the hypotenuse PR values are given. They didn't give QR, right? They asked you to find tan P minus cot R. So in order to find the tan ratio and cot ratio, what is the definition of tan? Tan is opposite divided by adjacent. So if we want to find tan P, we need the opposite side divided by adjacent side. Anyhow, we need the measurement of this side. So let us find the measurement of this side by applying Pythagoras theorem. This can be obtained by hypotenuse square minus this. So 13 square minus 12 square, which is 25. So QR will be 5 centimeter. Right? We found what is QR. Once we know what is QR, we can very well find what is tan P and cot R. What is tan P? Opposite side of angle P divided by adjacent side of angle P. So opposite side of angle P is QR divided by adjacent side of angle P is PQ. So QR divided by PQ, which is going to be 5 divided by 12. Alright. Next we need cot R. Cot R can be directly defined or you can write it as a reciprocal of tan R. If you are unable to remember the cot ratio or if you feel it is quite confusing which will be adjacent opposite or opposite by adjacent, you can remember any one ratio so that you can reciprocate it. So tan R is going to be opposite by adjacent. So for R it is going to be PQ divided by QR. But cot R is asked in the question. So reciprocate it. It will become 5 by 12. So when you subtract tan P and cot R, it is going to be 0 because both are 5 by 12 and 5 by 12. Right? It's very easy. Hope you understood. Let us solve the next problem. Now let us see how can we calculate our third problem. It is given if sin A equal to 3 by 4, calculate cos A and tan A. As I told you, if one trigonometric ratio is given, we can very well find the remaining 5 trigonometric ratios. Since we are dealing with the right triangle, we can find the other one using Pythagoras theorem. What is sin A? Sin A is opposite side to angle A divided by hypotenuse side. So this is your right triangle, right angled at B. Sin A is 3 by 4. Right, sin A is 3 by 4. So opposite divided by hypotenuse, which is BC divided by AC. Right, sin A is BC divided by AC, which is equals to 3 by 4. It doesn't mean that BC is equal to 3 centimeter and AC equal to 4 centimeter. Whenever we have it in a fraction, it means the ratio between those two is that much, right? So the ratio between the side BC and AC is 3:4. Yes, 3:4. So whenever we have it in ratio, we will take the values along with the variable. So BC we are going to take it as 3K and AC we are going to take it as 4K, where K is any positive number. Now with this, let us find what is our AB. AB can be written as AC square minus BC square by Pythagoras theorem. So 4K the whole square minus 3K the whole square. So if you expand and simplify it, we are getting 7K square. So AB is going to be root 7K. Right? Now we found what is our AB. So with this we can very well define the other trigonometric ratios. What is going to be cos A? Cos A is going to be adjacent side divided by hypotenuse. So AB divided by AC. What is the value of AB? Root 7K divided by AC is going to be 4K. So KK will get cancelled. So root 7 by 4. Similarly, tan A is opposite to A divided by adjacent to A. Opposite to A is BC, BC value is 3K, right? So 3K divided by adjacent to A is going to be AB, AB value is 7K. So 3K divided by, root 7K. K will get cancelled. So tan A is 3 by root 7. Hope you understood. This how only you have to find the trigonometric ratios if you know one trigonometric ratio. So how you should take it? You should not take it as an actual value. You should take it as a ratio. So the actual value will be taken along with some variable. Then apply Pythagoras theorem, find the third side in terms of that positive integer or variable. Then you can find the other trigonometric ratios. Anyhow, that variable will get cancelled since we are going to give the answers only in the ratio again. Yes, hope you understood, because any side can be found using the Pythagoras theorem. Right? Let us move on to our next question. Similarly, you can prove the next two questions. Given 15 cot A equal to 8, find sin A and secant A. So cot A is going to be 8 by 15. So taking that ratio, you can find the third side and you can very well find what is sin A and secant A. And cot, secant are reciprocal ratios. So be careful while writing your definition of the ratios, right? Then fifth question can also be solved in the same way. Secant theta is given. Secant is reciprocal of cos. So 13 gives 13 by 2 is the ratio between the hypotenuse and the adjacent side. So define your secant theta and then calculate all other trigonometric ratios. So I am leaving fourth and fifth to you. Now let us see how can we solve our sixth question. If angle A and angle B are acute angles such that cos A equals to cos B, then show that angle A equal to angle B. Now let us see how can we solve this. See what is given in the question. ABC is a right triangle in which angle A and angle B are acute angles. Angle A and angle B are acute angles. That's why we have taken angle C as right angle. Now given cos A equal to cos B and we need to prove angle A equal to angle B. Now what is the definition of cos A? Cos A is going to be the side adjacent to angle A divided by hypotenuse. Which is the side adjacent to angle A? AC. AC divided by AB. Similarly, cos B is going to be the side adjacent to angle B divided by hypotenuse. So it is going to be BC divided by AB. It is given that cos A equal to cos B. So AC by AB equal to BC by AB. So what does this imply? AC equal to BC. We got AC equals to BC. If these two sides are equal, then what do you know about these two angles? Will be equal by isosceles triangle property. This is by isosceles triangle property. Right? So hence we prove. That's it. Yes, hope you understood. Let us see the next problem. Now let us see how can we solve our seventh question. It is given cot theta equals to 7 by 8. They asked you to find this. You don't want to get panic on looking at the question. We can very well find the other trigonometric ratios if we know one, right? So find the trigonometric ratios, substitute in the question. That's it, you will get the answer. So for this we need the sine ratio, cos ratio, and for this subdivision we need cot ratio, which is already given in the question, right? So what is cot theta? Cot theta is 1 by tan theta. So if we consider this as a right triangle, I have taken this as theta. It is not necessary you should take this as theta. You can assume angle C also as theta, as your wish, right? Now cot theta is equals to 1 by tan theta. So tan theta ratio is opposite side divided by adjacent side. Since this is 1 by tan theta, it is going to be adjacent side divided by opposite side. Okay. So adjacent to angle theta is AB divided by opposite to angle theta is BC. So AB divided by BC. Now cot theta is given as 7 by 8. So AB I have taken it as 7K. BC we can take it as a 8K. So using these two we can find what is our AC. AC square is going to be AB square plus BC square. So 7K the whole square plus 8K the whole square. So it will become 49k square plus 64k square, which is 113k square. So what is your AC? Square root of 113k. Alright. Now we know all the three values. What is the value of AB? What is the value of BC? And what is the value of AC? Now very well we can solve the questions. So what is your first question? 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta into 1 minus cos theta. So what is a plus b into a minus b, which is a square minus b square. So numerator we can write it as 1 square minus sine square theta. So sine square theta, what it is, instead of writing sine theta the whole square, we will express square of trigonometric ratios like this. Sine square theta means sine theta the whole square. We need to multiply sine theta value 2 times. Okay. Divided by 1 minus cos square theta. Yes. So what is sine theta value now? So 1 minus, what is sine theta? Sine theta is going to be opposite side divided by hypotenuse. So which is side opposite to theta? BC. What is the value of BC? 8k. So it is going to be 8k divided by your hypotenuse is AC, which is square root of 113 by k. Then what is cos theta? Cos theta is adjacent side divided by hypotenuse. Here is theta. The side adjacent to theta is AB. So AB divided by AC. So 7k divided by 113k. So it will be 1 minus 7k divided by square root of 113k the whole square. So cos square sine square means the value whole square, right? So which is equals to k will get cancelled. So it will become 1 minus 8 8s are 64 divided by 113 because it is inside root. So if you square it, the root will vanish. 1 minus 7 7s are 49 divided by 113. Now you have to take LCM. 113 minus 64 divided by 113, the whole divided by 113 minus 49 divided by 113. So these two will get cancelled, right? So 113 minus 64 is 49. 113 minus 49 is going to be 64. So this is 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta into 1 minus cos theta value, right? Your second subdivision is cot square theta, which is nothing but cot theta the whole square. What is cot theta value given in the question? 7 by 8. So 7 by 8 the whole square, which is 49 by 64. So we got the same answer. Okay, in forthcoming topics we will be learning what is 1 minus sine square theta and 1 minus cos square theta. 1 minus sine square theta is cos square theta. 1 minus cos square theta is sine square theta. So we will get cos square divided by sine square, which is nothing but cot square theta only. That's why we got both the answers to be same, because this is nothing but cot square theta. In the forthcoming topics we will be learning identities. In that you will come to know, right? But as of now we have found the values and we have substituted in the question and we arrived at the answer. Hope you understood. Let us move on to the next question now. 8th and 9th question are in the same way, so I am leaving it to you. You can find the trigonometric ratios values and you can substitute and find the question which is given there. Let us move on to our 10th question. In triangle PQR, right angled at Q, PR plus QR equal to 25 centimeter and PQ is 5 centimeter. Determine the values of sin P, cos P and tan P, right? So this is what given in the question. PQR is a right angle triangle, right angled at Q. PR plus QR is 25 centimeter, PQ is 5 centimeter. So we need to find, only if you know all the three sides, we can easily find the trigonometric ratio. So let us assume any one side as x. Now I am going to assume QR as my x. Okay. So let QR is equal to x centimeter. Then PR square will be equals to PQ square plus QR square, right? What is PQ? Phi square plus QR is x square. Now again, if I have one more unknown variable, we cannot solve it. So try to express PR in terms of x. PR plus QR is 25. So PR can be written as 25 minus QR. So this is 25 minus QR the whole square. Since PR plus QR equals to 25 centimeter, which is given in the question. Now what is QR? QR we have assumed it as x. So this is going to be 25 minus x the whole square, which is equal to 5 square plus x square. Now expand using a minus b the whole square identity. What is 25 square? It is going to be 625. So 625 plus x square minus 2ab, 2 into 25 into x. So 2 into 25 is 50x equals to 5 5s are 25 plus x square. So x square will get cancelled. So bring this 25 to this side and minus 50x to other side. 625 minus 25 equals to 50x. So it is going to be 600 divided by 50x, or x is equals to 600 divided by 50. So 5 12s are. So x is equals to 12 centimeter. Right? Once we know what is x, we can very well find what is PR and QR. So this implies QR equals to 12 centimeter and PR is equals to 25 minus 12. What is 25 minus 12? 13 centimeter. So PR is 13 centimeter and QR is 12 centimeter, and already it is given in the question PQ as 5 centimeter. So we know all the three sides. So we can very well find what is sin P, cos P and tan P, right? So hope you will complete this problem. The last question is just true or false. Let us discuss the true or false questions. The value of tan A is always less than 1. No, it is not necessary the value of tan A should be always less than 1. It depends on the ratio what are we going to obtain. So it is false. Secant A equal to 12 by 5 for some value of angle A. How will you analyze this? If it is going to be 12 by 5, it is going to be greater than 1. The value is going to be greater than 1, right? What is the definition of secant A? Secant A is the reciprocal of cos. So it will be hypotenuse divided by adjacent side. And we know in a right triangle, hypotenuse is going to be the longest side, right? So the measurement, when we have hypotenuse divided by adjacent, hypotenuse is the greatest number divided by the smaller number. When the numerator is greater than the denominator, obviously we will have a value greater than 1 only. So secant A is always greater than 1, and hence secant A can be 12 by 5 for some value of angle A. It is possible. So it is true. What cos A is the abbreviation used for the cosecant of angle A. No, it is false. Cosecant of angle A, we will write it as cosec A, and cos A is the abbreviation for cosine. Cosine is different from cosecant, right? Cosecant is the reciprocal function, which is the reciprocal of sine. Okay, so cos A is the abbreviation of cosine function, C-O-S-I-N-E, cosine function. Cosecant will be cosec function. So it is false. Fourth one, cot A is the product of cot and A. No, it is not a product. I told you, no, the trigonometric ratios doesn't have any value without the angle. So cot doesn't have any meaning without A. So A is accompanying cot. So it is cotangent of the angle A. It is not the product of cot and A, so which is false again. And fifth one, sin theta. Sin theta equal to 4 by 3 for some angle theta. This can be argued in the same way as we did the second subdivision. If you see sin theta equal to 4 by 3, which is greater than 1, right? But when you take the definition of sin theta, it is going to be opposite side divided by hypotenuse. Hypotenuse is the longest side. So the denominator is greater than the numerator. So obviously the value will be less than 1. So there is no possibility for sine values to become greater than 1. Therefore we cannot have sin theta equal to 4 by 3 for some angle theta. So whenever you have questions like this, second and fifth one, you have to do your argument in this way. Check whether the value is greater than 1 or less than 1. Check out the definition of the given trigonometric ratio, and if the hypotenuse lies in the numerator, check whether it lies in the numerator or in the denominator, because the hypotenuse is going to be the longest side. Accordingly give your conclusion, right? So with this, let us wind up today's class. So in today's class we have learnt only about the trigonometric ratios, sine, cosine, tangent and the reciprocal of all these functions. Reciprocal of sine function is cosec function, cosecant function. The reciprocal of cosine function is secant function. The reciprocal of tangent function is cotangent function. We will call it as cosec, sec and cot, right? Hope you understood, and if you have any doubts you can ask me. Do these problems as homework and post it in the group without fail. Thank you, students.